We have liftoff of the Titan Centaur carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
Voyager 2 went dark for months, then suddenly sent a message no one saw coming. What it transmitted wasn't just routine data, but something far more unsettling. Dormant systems coming back online, strange, unexplained patterns, and even distorted echoes of its own signal.
That commander computer system on Voyager 2, a single digit has been flipped from a 1 to a 0.
Some dismiss it as a technical malfunction. Others suspect the probe may have crossed into something entirely unknown, a presence, a force, perhaps even an intelligence lurking in the vast emptiness of space.
It's almost like somebody reprogrammed the probe.
What if Voyager didn't just survive, but made first contact? In this video, we dive into the bizarre signals, the haunting silence that followed, and the chilling possibility that space isn't empty at all. It's aware, and it's been listening. The birth of Voyager 2. Humanity's journey into space has been nothing short of breathtaking, and sometimes a little crazy. Think about it. Not too long ago, our idea of flying was tying a big cloth to a basket and floating around in a balloon. Then came airplanes, and before we knew it, we were strapping satellites to giant rockets and literally launching chunks of metal. And at one point, animals, into the void. Why? Because we've always been curious. From the moment our ancestors looked up at the night sky and wondered what those tiny lights were, we've been obsessed with understanding the vast, mysterious space that surrounds this little blue dot we call home. And that's where Voyager 2 comes in. This isn't just a story about a machine made of wires, metal, and plutonium. It's about humanity's bold attempt to send a message, and a pair of robotic explorers, into the deep unknown. Voyager 2 wasn't just another NASA project. It was a gamble, a dream, and a bridge between science fiction and reality. It was built to defy the odds and take us farther than we'd ever been before, to help us unravel the mysteries of our solar system and maybe even meet whatever might be out there. And recently, it has found something that aroused the curiosity of the entire world of science. Billions of miles from Earth, NASA has just caught a mysterious heartbeat from its long-lost Voyager 2 probe, and this discovery has sent shockwaves through the space community. The legendary spacecraft went silent, cutting off all communication. For weeks, Voyager 2 drifted through the cold, dark void, unable to send or receive data, a ghost ship lost in interstellar space. But then, during a routine scan of the sky, NASA's massive radio dish in Canberra, Australia, detected something extraordinary, a faint signal pulsing like a cosmic heartbeat. The moment was electrifying, a sign that Voyager 2 was still alive and possibly not alone. NASA scientists are now blasting commands back toward the probe, desperately trying to regain full contact. The big question, was this just a stray signal from Voyager 2, or did the probe encounter something entirely unknown out there, in the uncharted depths of space? This all started back in the 1970s. The world was in the grip of the Cold War, a tense standoff between the United States and the Soviet Union. These two superpowers weren't just battling ideologies, capitalism versus communism. They were locked in a technological arms race, and outer space became their ultimate arena. The Soviets had already shocked the world in 1957 by launching Sputnik, the first ever artificial satellite. Then, in 1961, they upped the ante by sending Yuri Gagarin, the first human, into space. The United States couldn't let that slide. Their answer? The Apollo program, culminating in humans walking on the moon in 1969. By the time the 70s rolled around, NASA wasn't content with just reaching the moon. They wanted to go beyond. Not just to Mars or Jupiter, but to send probes past the outer planets and into interstellar space, literally leaving the solar system behind. But there was a problem. Deep space isn't exactly a friendly neighborhood. It's vast, cold, and full of radiation, and getting there requires both incredible precision and perfect timing. NASA's big opportunity came in the form of a rare planetary alignment, a cosmic lineup of Jupiter, Saturn, Uranus, and Neptune that happens only once every 176 years. This alignment would allow a single spacecraft to visit all 4 outer planets by using their gravity like a cosmic slingshot. The mission was ambitious. Launch 2 probes, each capable of traveling billions of miles, sending back never-before-seen data and images, and eventually crossing the invisible boundary into interstellar space. Here's where it gets a little quirky. Even though Voyager 2 was launched before its twin, Voyager 1, it ended up being named 2. Why? Because NASA expected Voyager 1 to overtake its sibling and reach certain planetary encounters first, so the numbers were based on order of arrival, not launch. Yeah, it's confusing, but it worked out in the end. The dual purpose of the mission was clear: to boldly go where no probe had gone before, exploring the giant outer planets and their mysterious moons. And once its main mission was complete, Voyager 2 would continue traveling, silently, endlessly, carrying humanity's message into the stars. But here's where things get really poetic. NASA didn't just send a scientific instrument into the void, they sent a message in a bottle, the famous golden record. This gold-plated phonograph record carries sounds and images representing life on Earth. Greetings in 55 languages, music from Bach to Chuck Berry, recordings of ocean waves and birdsong, and even the sound of a baby crying. It was humanity's way of saying, "Hey universe, we're here." Just in case someone, or something, ever finds it. And it appears someone or something has, at least that's why the latest message from Voyager 2 implies. Voyager 2's epic journey. On August 20th, 1977, as the Florida sun rose over Cape Canaveral, a crowd of engineers, scientists, and space enthusiasts gathered with bated breath. The countdown began. A thunderous roar shook the ground as Voyager 2, a fragile machine of wires and metal, strapped to a massive Titan IIe Centaur rocket, soared into the sky. That moment was the beginning of one of the greatest adventures in human history, exploring the uncharted outer reaches of our solar system, visiting worlds so far away that until then, they'd only been blurry dots in telescopes. For nearly 2 years, Voyager 2 sailed through the cold, dark expanse of space, quietly collecting data and sending faint radio whispers back to Earth. Then, in July 1979, it reached its first destination, Jupiter, the king of planets. What Voyager 2 sent back changed everything. For the first time, humanity got a close-up view of Jupiter's swirling, violent atmosphere. The Great Red Spot, a storm so massive it could swallow 3 Earths whole, wasn't just a colored smudge in a textbook anymore. It was a living, churning tempest caught on camera. But Jupiter had an even bigger surprise waiting. Its moons, though, were beautiful. When scientists analyzed Voyager's images, they were stunned. Io wasn't the dead, cratered rock they expected. It was alive with volcanic activity, erupting with plumes of molten sulfur that shot hundreds of miles into space. No one had ever seen anything like it. For the first time, we realized other worlds could be geologically active, reshaping our understanding of the solar system. As Voyager 2 departed Jupiter, it performed its first gravity assist maneuver, using the giant planet's pull to slingshot itself toward its next target, Saturn. By August 1981, Voyager 2 was closing in on Saturn. Even from afar, the planet looked majestic, surrounded by its shimmering icy rings. But up close, it was jaw-dropping. Voyager 2 revealed that Saturn's rings weren't solid disks, as once believed, but intricate bands made of billions of ice particles, ranging in size from dust grains to mountain-sized chunks. The spacecraft captured stunning images that showed gaps, braids, and mysterious wave-like patterns rippling through the rings, clues that hinted at complex gravitational interactions we still don't fully understand today. And then there were the moons. Saturn's largest moon, Titan, turned out to have a thick, hazy atmosphere, rich in organic compounds, the basic building blocks of life. It was like peering back in time, seeing what early Earth might have been like billions of years ago. Voyager 2 also discovered bizarre little moons like Enceladus and Mimas, each with their own strange features. These worlds were no longer just dots of light in the sky. They were dynamic, alien landscapes. Once again, Voyager 2 used Saturn's gravity to hurl itself even farther outward, toward a planet so distant that no spacecraft had ever been there before. On January 24, 1986, Voyager 2 made history. It became the first, and still the only, spacecraft to visit Uranus. Until then, Uranus was little more than a pale blue dot through a telescope, shrouded in mystery. Voyager 2's arrival changed that overnight. It discovered 10 new moons, examined the planet's faint ring system, and revealed Uranus's atmosphere in detail for the first time. But perhaps the strangest find was Uranus's magnetic field. Unlike Earth's neatly aligned magnetic poles, Uranus's field was completely tilted and off-center, like someone had dropped a bar magnet inside the planet at a weird angle. This bizarre configuration baffled scientists and hinted that Uranus was a far more complex world than anyone had imagined. Even its rotation was odd. Uranus is tipped on its side, rolling through space like a spinning barrel, giving it some of the strangest seasons in the solar system. With another successful flyby under its belt, Voyager 2 didn't stop to rest. It adjusted course one last time, setting its sights on the farthest planet it would ever visit, Neptune. By August 1989, after more than a decade of travel, Voyager 2 reached its final planetary stop, Neptune, a mysterious ice-cold giant at the edge of the solar system. Neptune did not disappoint. Voyager 2 sent back breathtaking images of the planet's deep blue atmosphere, revealing massive dark storms, including the now famous Great Dark Spot, a swirling hurricane nearly the size of Earth. Its largest moon, Triton, turned out to be just as fascinating. Triton wasn't a frozen, lifeless rock. It had geysers of nitrogen blasting into space, hinting at internal heat and perhaps even subsurface oceans. This made Triton one of the most intriguing candidates for potential habitability beyond Earth. The flyby was a bittersweet milestone. As Neptune's pale blue dot faded behind it, Voyager 2 completed its grand tour, the first and only mission to visit all 4 outer planets. There would be no more planetary stops. Ahead lay only the vast, uncharted darkness of interstellar space. After its encounter with Neptune, Voyager 2 crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. At this point, Voyager 2 became one of only 2 human-made objects to achieve this feat, the other being its sibling, Voyager 1. The probe now travels through a realm we've never physically explored, where cosmic radiation reigns and the nearest star is still light years away. And somewhere, out there in the endless dark, maybe, just maybe, something is listening. But more than the messages the Voyager 2 has been able to send back to us, it's also revealed one thing about the vast space outside our world. A harsh world, and maybe something else, might be out there. The signal that shouldn't exist. Space is silent, deafeningly silent. For decades, Voyager 2 has drifted alone in the vast, endless dark, its faint radio whispers taking more than 18 hours to reach Earth. It's been our tireless messenger at the edge of the known universe. But in July 2023, that silence grew deeper than ever. Voyager 2 went dark. On a quiet day in July, NASA's Deep Space Network, a global web of giant radio antennas, stopped receiving data from Voyager 2. At first, it wasn't full-blown panic. These things happen occasionally, maybe a small glitch, maybe a temporary communication delay caused by space weather. But as hours turned into days and days into weeks, concern began to creep in. NASA engineers soon suspected the culprit: antenna misalignment. Somewhere, billions of miles away, Voyager 2's tiny high-gain antenna had likely drifted out of position by just 2 degrees. 2 degrees may not sound like much, but at Voyager's distance, it's like trying to hit a moving target the size of a dime from across the continent. If this was the issue, it meant Voyager was screaming into the void, unable to hear or be heard. For the first time in 46 long years, humanity's connection to one of its greatest explorers had been severed. NASA publicly announced they were working on a blind command, a last-ditch attempt to shout instructions into the abyss and hope Voyager was listening. Quietly, though, many feared this was the end. After nearly 5 decades, Voyager 2 might finally be lost forever. Then, without warning, something happened. On a routine monitoring shift, a technician noticed a strange blip on their console. A strong signal, unmistakable, powerful, was coming from Voyager 2's exact location. The room fell silent. At first, they thought it was a mistake, maybe interference or a stray transmission. But as they listened, the signal grew clearer and stranger. Voyager 2 wasn't just back online, it was behaving differently. Long dormant systems, instruments that had been powered down decades ago to conserve energy, suddenly reactivated on their own. Subsystems that engineers were certain were beyond repair seemed to flicker back to life. It was as if Voyager 2 had been woken up by something in space. No one had sent the command. No one understood how this was even possible. The first priority was to capture and decode the returning signal. What they found was unsettling. At first glance, it looked like routine telemetry, the usual health and status updates Voyager 2 had been sending for years. But buried within the data were anomalies that didn't make sense. Certain parts of the signal sounded eerily like Voyager 2's own transmission, as if something out there had caught the signal, bent it, and sent it back. It wasn't a clean reflection, more like an echo twisted into unfamiliar shapes. Radio signals usually contain noise, random static generated by space itself. But sections of Voyager 2's new transmission weren't random at all. They contained structured, repeating patterns, the kind of thing engineers expect only from designed systems, not natural phenomena. Some of the frequencies Voyager 2 was using didn't match its original programming. It was as if something had added to the signal, or Voyager 2 had learned a new way to talk. The more they studied it, the stranger it became. NASA's public line was cautious. "We are investigating unexpected telemetry issues." Behind closed doors, however, engineers whispered about what they were really seeing, something that shouldn't exist. As the data circulated, different camps formed around what could explain this cosmic mystery. The most grounded explanation was that Voyager 2 was simply breaking down. After all, it's been out there for decades, bombarded by cosmic radiation and micrometeorites. A surge of radiation could have scrambled its software, causing it to switch systems on and off randomly. In this view, the strange patterns in the signal weren't messages, just the confused ramblings of a machine at the end of its life. Others argued for a more exotic but still natural explanation. Voyager 2 had crossed into interstellar space, a region humanity knows almost nothing about. Out there, strange plasma waves and magnetic anomalies could bend or distort radio waves in ways we don't fully understand. Maybe the echoes and patterns weren't artificial at all. Maybe they were simply Voyager 2 encountering alien physics, not alien intelligence. Then there were the quiet few who dared to ask the most unsettling question of all. What if this wasn't a malfunction or a quirk of physics? What if something out there responded? The structured nature of the patterns, the way the signals seemed to mimic Voyager's own voice, the sudden reactivation of long-dead systems. To some, it felt less like random chaos and more like communication, a conversation starter, perhaps. If true, it wouldn't just mean that space isn't empty. It would mean it's aware, watching, listening, and now speaking. When news of the signal broke, NASA faced a dilemma. Publicly, they had to remain calm, rational, and above all, scientific. Their official explanation was simple. Voyager 2 experienced a temporary systems anomaly. The situation is under control, but internally, the tone was very different. Leaks suggest that certain teams are still quietly investigating the anomalies, combing through every byte of data for answers. Some engineers have reportedly been warned not to speculate publicly, especially about the contact theory. Voyager 2's unusual behavior. Besides the strange signal, Voyager 2 has been doing way more than that. It was built to be predictable, methodical, and utterly dependent on the commands sent from Earth. But lately it hasn't been acting like itself. In fact, it's been behaving like something with a mind of its own. When NASA first noticed Voyager 2's odd behavior, engineers thought it had to be a glitch, a random hiccup caused by aging hardware or cosmic radiation. But as the weeks went on, the anomalies piled up. Voyager 2 began switching between its main and backup systems entirely on its own, with no commands sent from Earth. It rerouted data streams, reconfigured subsystems, and even adjusted its orientation slightly, all actions completely outside its original programming. Think about it this way. It's like your old computer suddenly deciding to restart, update its software, and rearrange your files without you touching a thing. Except this computer is 12 billion miles away, and there's no Wi-Fi password you can reset. Even stranger, the changes seemed reactive, as if Voyager 2 were responding to something external, some kind of unseen influence in the void. NASA's official logs describe it as unexpected autonomous decision-making. Unofficially, some engineers have been whispering another word: awareness. Now, before we jump to wild conclusions, there are logical possibilities. Voyager 2's hardware is ancient, built long before modern safeguards and redundancy checks were perfected. Over the years, tiny particles of cosmic radiation may have corrupted parts of its memory, essentially rewriting its code in unpredictable ways. In theory, this could make the probe behave erratically, like a robot with scrambled instructions. But here's the kicker. These decisions don't feel random. They appear purposeful, even strategic. For instance, at one point, Voyager 2 powered up an old backup transmitter that hadn't been used in decades, a move that directly improved its communication signal. There's no reason a corrupted system would just happen to do that by chance. It's as though something out there is guiding it. If this were happening only to Voyager 2, maybe it could be written off as a one-off fluke, but it isn't. In 2022, its sibling probe, Voyager 1, began showing its own mysterious behavior. For several months, Voyager 1 started sending back nonsensical telemetry data, garbled readings that didn't match its actual status. Engineers eventually managed to correct the issue, but no one could explain why it happened. Now, with Voyager 2's even more dramatic anomalies surfacing just a year later, some scientists are starting to wonder, is this mere coincidence? Or are both probes encountering the same strange phenomenon out there in interstellar space? It's like two hikers walking different trails through a dark forest, and both suddenly reporting the same eerie feeling that someone's watching them. Here's where things get even more intriguing. This isn't the first time humanity's deep space explorers have defied explanation. Back in the early 2000s, scientists studying data from the Pioneer 10 and Pioneer 11 spacecraft noticed something odd. Both probes were drifting slightly off course, in a way that couldn't be explained by gravity, solar radiation, or any known force. This mysterious deviation became known as the Pioneer anomaly. While later studies suggested heat emissions might account for part of it, the exact cause was never fully settled. Could Voyager 1 and Voyager 2 now be experiencing a modern echo of that same mystery, not in their trajectories this time, but in their behavior? It's a chilling possibility. Something in the vast darkness beyond our solar system, subtly influencing our machines, and maybe even testing them. To truly grasp how strange this all is, you need to understand where Voyager 2 is right now. As of today, the probe is more than 12 billion miles from Earth. That's so far away that a radio signal, traveling at the speed of light, takes 18 hours just to reach it. It has crossed the heliopause, the invisible boundary where the sun's influence ends and interstellar space begins. Beyond this line, there are no planets, no comforting streams of solar wind, just the uncharted wilderness between stars. No human-made object, except for Voyager 1, has ever been here before. Voyager 2 is literally in alien territory, and we're flying blind. So what's out there? The short answer, almost nothing, and that's what makes it so unnerving. Interstellar space is a realm of extremes. It's a near-perfect vacuum, with only a few stray particles drifting in every cubic inch. The magnetic fields are faint and chaotic, unlike the orderly patterns within our solar system. Imagine standing in a vast, dark desert where even the air has been stripped away. That's Voyager 2's world now, silent, cold, and eerily still. But just because it seems empty doesn't mean it is. Subtle currents of plasma flow through this void, invisible forces we barely understand. Even a tiny anomaly could have dramatic effects on a lone spacecraft wandering so far from home. And somewhere, far beyond the heliopause, the little probe keeps moving, alone in the dark, its behavior growing stranger with every passing year. The harsh reality of space. Space. It might look beautiful from the comfort of Earth, all those glittering stars against a velvet black backdrop. But make no mistake, space is a nightmare for machines. It's the most hostile, unforgiving environment imaginable, a place where even the tiniest miscalculation can spell doom. For Voyager 2, a probe built with less computing power than a basic digital watch, surviving nearly 5 decades out there, is nothing short of miraculous. But to understand why that's such a big deal, you first need to know what space does to machines like Voyager 2. On Earth, we complain when it's too hot or too cold, maybe 40 degrees Celsius in a heat wave or minus 10 degrees Celsius in a brutal winter storm. Space laughs at those numbers. Out there, temperatures swing wildly from minus 200 degrees Celsius to over 130 degrees Celsius, depending on whether a spacecraft is facing the sun or hiding in the darkness. Imagine being baked in an oven 1 second and then instantly tossed into a freezer the next. That's what Voyager 2 endures constantly as it hurtles through the void. These violent temperature swings can wreak havoc on delicate electronics and metal parts. Materials expand when they heat up and contract when they cool. And over time, this repeated stress can cause cracks, fractures, or outright system failures. NASA engineers had to design Voyager 2 like a cosmic camel, able to withstand both extremes without falling apart. Its body is wrapped in special insulation to protect sensitive instruments, and its systems are carefully positioned to avoid cooking or freezing. Even then, every passing year increases the risk of temperature-related breakdowns. Temperature swings are bad enough, but there's another danger lurking in deep space: radiation. Here on Earth, we're protected by our planet's magnetic field, which shields us from most of the sun's harmful particles. Voyager 2, floating billions of miles away, has no such luxury. It's constantly bombarded by cosmic rays, high-energy particles moving near the speed of light. These particles don't just damage electronics, they scramble data. A single cosmic ray strike can flip a 1 to a 0 in the probe's ancient memory banks, corrupting commands or crashing systems entirely. To make matters worse, Voyager 2 is now traveling through interstellar space, where the density of these cosmic rays is even higher. It's like swimming through an invisible storm of radioactive bullets. The fact that Voyager 2 still manages to receive and execute commands is nothing short of extraordinary, and a testament to the ruggedness of its engineering. Space might seem empty, but it's not. Tiny fragments of rock and metal, some no bigger than grains of sand, zip through the void at tens of thousands of miles per hour. These are called micrometeorites, and when one slams into a spacecraft, it's like being hit with a microscopic bullet. Over time, countless impacts can wear down surfaces, punch holes in insulation, or even destroy critical components. Voyager 2 has no armor. It relies purely on luck, careful orientation, and a bit of sturdy design to avoid catastrophic damage. After more than 4 decades, it's safe to say the old spacecraft has taken more than a few hits, and survived them all. So how has this 1970s spacecraft managed to keep going while other machines would have failed decades ago? The secret lies in its brilliantly simple design and clever engineering. At its heart, Voyager 2 is powered by a radioisotope thermoelectric generator, essentially a nuclear battery fueled by plutonium-233. This power source is what allows Voyager to keep its instruments warm and operational, even in the frigid darkness where sunlight is far too weak for solar panels. But there's a catch. The RTG loses about 4 watts of power per year as the plutonium decays. In 1977, it generated 470 watts, about enough to power a small household appliance. Today, it's down to less than 250 watts, forcing NASA to make tough choices. To keep Voyager alive, engineers have been systematically shutting down non-essential systems, one by one, leaving only the most critical instruments active. It's like turning off the lights in every room of a house, except for a single lamp, just enough to keep the place habitable. This minimalist strategy has allowed Voyager 2 to continue sending data, even as its energy dwindles to a faint trickle. It's the deep space equivalent of running on fumes. When you add it all up, the freezing cold, the radiation, the constant micrometeorite bombardment, and the crushing loneliness of distance, it's almost unbelievable that Voyager 2 is still out there, faithfully carrying out its mission. But science never waits, as humans are way too impatient to depend on just one source of information, especially as this has to do with space, an area we still know very little about despite the many tries. Before there were Voyagers, there were Pioneers. Pioneer 10, launched in 1972, was the first spacecraft to fly past Jupiter and escape the Sun's gravitational pull entirely. It carried a golden plaque, much like the Voyager Golden Record, with a simple message about humanity's location and appearance, just in case it was ever found by intelligent life. Pioneer 11, its twin, followed a similar path, making the first ever Saturn flyby and paving the way for future missions. These probes didn't just gather groundbreaking data, they proved it was possible to travel beyond the solar system at all. Even when they stopped transmitting, their trajectories caused a small mystery known as the Pioneer anomaly, an unexplained deviation in their paths that scientists still debate to this day. Fast forward to the 21st century, and along comes New Horizons, a probe with one of the most daring missions ever attempted, a flyby of Pluto, the most distant planet in our solar system. Launched in 2006, New Horizons traveled over 3 billion miles to give us our first close-up images of Pluto in 2015, revealing towering ice mountains, heart-shaped plains, and a world far more dynamic than anyone expected. After Pluto, it kept going, venturing into the Kuiper Belt, a mysterious region filled with icy remnants from the birth of the solar system. Even now, it continues to beam back data, helping us understand the outer reaches of our cosmic neighborhood. Voyager, Pioneer, and New Horizons were all incredible achievements, but they relied on decades-old technology. The next generation of exploration tools looks like something straight out of science fiction. And some of it is. Launched in December 2021, the James Webb Space Telescope isn't a probe, but it's revolutionizing how we see the universe. Where the Hubble Space Telescope gave us breathtaking images of galaxies and nebulae, James Webb takes it to another level, peering 13 billion years into the past to study the very first galaxies that ever formed. It uses infrared vision, allowing it to see through cosmic dust clouds and detect the faintest signals of ancient starlight. Every image it sends back is like a postcard from the dawn of time. Proof that space exploration isn't just about distance, but about depth. While our robotic probes roam the outer solar system, NASA is also gearing up to send humans back into space in a big way. The Artemis program aims to land astronauts on the moon again. this time to stay. Artemis will test new habitats, resource harvesting techniques, and even potential spacecraft that could someday take us to Mars. It's like building a cosmic base camp, turning the moon into a launch pad for deeper exploration. The Voyagers are fast, but here's the catch. Even at their incredible speed, they'd take 75,000 years to reach the nearest star system, Proxima Centauri. If we want to explore beyond our solar system in any meaningful way, we need better engines. Imagine a future probe reaching another star within a human lifetime instead of millennia. It sounds like science fiction, but so did Voyager back in the 1970s. Every mission builds on the legacy of the ones before it. Without pioneers, there would be no Voyagers. Without Voyagers, New Horizons might never have flown. And without today's cutting-edge tech like James Webb and Artemis, we'd never dream of sending the next generation of probes to other star systems. While we're yet to confirm our first alien contact, we already know that there's a whole new world out there waiting for us. Thanks for watching. See you in our next video.